Hello, I'm Paulo Barrelas and I'm going to walk you through this Introduction to Redshift training. This will be just a short introduction and we will be learning about how we can create a Redshift physical light, a Redshift material, a Redshift physical camera, and play with some of the settings. You will also have access to the files so we can follow along. And with no further ado, let's get started. Okay, so after you set up your Redshift account, you come here to the download section, and here you will find installers for Windows, Mac, and Linux. In my case, I'm under Windows. This is the one that I would download to install Redshift on my machine. But I'm not going to because it's a really straightforward process and I'm not going to bore you to death. One thing that you need to be aware of is that Redshift will check itself on for all the versions and applications supported by it. If for any reason you don't want it to be installed for any of those, you just need to manually uncheck. Okay, so once the process is concluded, you just need to go here to the dashboard section, click on the activation keys tab and copy the license. I'm going to bring in the Redshift licensing tool. You click activate license. You just need to paste and activate. So the process was successful. Now we are ready to dive into our scene. So here we've got our scene, and as you can see, it's a very simple scene. We've got a tabletop and the 14 pool balls. And before we start adding anything else to the scene, let's talk a little bit about the Redshift render view. And in order to load it, we go here to the Redshift top menu and click on Redshift render view. And the first button is for rendering final images. Let's click here on the second one, which is for starting and stopping the interactive progressive rendering. And as you can see, now we are able to preview almost in real time whichever changes we are doing to our scene. The next one is for forcing a refresh. So every time I click on it, we can see that the progressive rendering bar restarts calculating. This drop-down menu is for previewing AOVs. We don't get anything else but the beauty because we didn't set up anything, and we are not going to touch on this subject on this training. The next is for previewing individual RGB and alpha channels. This button is for focusing on just a region of our frame, so we can resize this region like so. The next button is for locking a particular camera to the render view. And for that, let's create a Redshift camera. And we've got two ways of creating a Redshift camera. One is through the default scene for the camera, and by right click on it, we go here to Redshift tags, Redshift camera. So let's delete it. The other one is through the Redshift top menu. So we go to cameras and click on the stand-up camera, like so. So when we look through this camera, and now we make all the camera changes, the render view is looking through that particular camera. And this is why this button is very handy, because we can lock the render view to that camera. Now, if I use the default camera, as you can see, we are always previewing the scene through the locked camera. So with this camera selected, I'm going just to use here some particular numbers. And now let's right click and use a protection tag. And with the Redshift camera, let's just change the focal length to 50. And let's click on the Redshift camera tag. Let's go to the exposure tab. Let's enable it. And let's use an ISO of 400, like so. Now let's create a Redshift area light, and we need to go here to the Redshift top menu, lights, area light, like so. Let's actually unlock the camera so we can really see what we are doing here. So let's rotate this light 90 degrees, like so. Let's move it on the Y. And as you can see, we are able to really preview almost in real time all the changes that we do here. And we can use these handles here to resize the light. One cool thing about the 3D representation of a redshift light is that we've got here these lines on the corners, which is giving us the information that it's facing that direction. So it's always facing the Z axis, but it's very easy for us without having the light selected to know which direction it's facing. So with the light selected, let's just use here some numbers too. And let's also resize the light in order to use 50 by 50 centimeters. So let's look through the camera again. Let's lock it. One thing that Redshift can do to some extent is to translate default cinema 4D lights. Of course, we don't get any of the Redshift options. So the next button is for switching between the progressive mode and the bucket mode, like so. So these small squares that you saw, I don't know if the recording software was able to capture that, is the bucket mode. So it's already rendered because we are not going through all the passes that we've got set up here by choosing Redshift. These are the passes that Redshift is using in the progressive mode. So this bar is going through all these passes here. Of course, you can change this number. So the difference between the progressive mode and the bucket mode is that the progressive rendering should be used while tweaking the things because it offers faster feedback than the bucket rendering. It operates in a brute force way without using any point-based techniques like photons, caustics, or irradiance caching. The bucket rendering uses the number of samples and will render clean images faster than the progressive rendering and is more optimized in Redshift, so it should be used for optimizing and final renders. So that's why, of course, when we've got the bucket rendering selected, if we, let's say, change something, you can see that we are also be able to preview, but it takes more time. So the same thing with the progressive, we can preview it in a faster way. So the next button is for freezing the tessellation when we are using a Redshift object tag. We are not using the object tag on our scene. This button is for switching between the regular mode, which is the one we are using right now, a clay mode, which is very handy for previewing light and GI without the color, reflection, and refraction information from our materials. And this is the samples mode, which is for optimizing purposes. These three buttons here is for snapshots. So if we click here on the middle one with a plus, we are able to take a snapshot of the current scene state. If we make a change, let's say like this, we are able to take another one and we can go through both of these snapshots. The first button is for turning on and off this area here. And the third one is for sending a snapshot to the picture viewer, like so. So let's create our first material. And for that, we've got two options. One is through the Create menu, Redshift Materials material. And the other one is through the top menu. We go to Materials, Material, Material. We've got all these options here, but let's just focus on the generic material that will serve you most of the time. So with the materials selected, we've got here options for the base properties, which refer to the diffuse, reflection, refraction, and subsurface properties. And we've got all these other tabs with more options. For this training, let's just focus here on the reflection right now. So let's load the Redshift render view. Let's start the interactive rendering. And here the roughness serves to control how blurry the reflections are. So let's apply this Redshift material to our number one ball. And I want to change how the reflections look. So in order to do that, let's go here to the roughness. And as you can see, while I'm increasing the value, the reflections are getting more blurry. Of course, that a pool ball material hasn't a reflection like this, so let's just going to use a value of 0.09, and I'm now going to use a texture to give the color information to the material. And for that, let's go here and click on Edit Shader Graph. And now let's just drag this to the side like so. And now we are able to really play with all the features of a shader graph, which is a lot more powerful than the default Cinema 4D material creation method. Here on the left side, we've got our node library. We are just interested right now on clicking and dragging a texture node here. And with the texture node selected, we've got here on the right side the options for that particular selected node. If we click here on the three dots, we are able to load the texture. And now let's click here on these output ports, drag and drop onto these blue square and choose base properties, diffuse color. Another way to create textures or bring textures onto the shader graph is through dragging and dropping onto this area here. And let's drag and drop. And as you can see, the texture nodes got automatically created with the texture already loaded and with the same name as the texture, which is very handy. So let's plug this, and as you can see, it's working perfectly. This is a very versatile and powerful way of creating our materials because we can immediately preview here just by looking at the shader graph what is going on. So by clicking Control and double clicking here on the node title, we can see that now we are fitting a texture into the diffuse color of a material. And as a very quick example, if I select the table material here, we can see that the same texture is fitting the diffuse color channel and is also being used to generate the bump map for the same material. So it's very powerful. Okay, so now I'm going to duplicate this material and build the material for the remaining balls and apply those to the scene. Okay, so here we've got our scene with all the materials created and applied to the respective balls. One thing worth mentioning is that Redshift to some extent can translate Cinema 4D shaders and materials. Okay, so let's start the IPR using this second button. Let's go and select the Redshift camera tag. Let's go here to the exposure tab and let's play a little bit with the vignetting. So the vignetting, this effect darkens the corners of the image as in the real camera, like so. But for this image, let's use probably a value of 5. Okay, it's fine. And now let's go here to the bokeh tab and let's enable it. And as you can see, the effect is too strong because everything is out of focus. Right now, we are deriving the focus distance from the camera. If we select the Cinema 4D camera, as you can see, we are using a value of 2000 centimeters. Of course, we can play either with this value, let's say using a value of 50, or we can go and let's go back, something like that. Let's go here to the Redshift camera tag. Let's uncheck this setting. Let's use the same value here. Either way, it's going to give us the same effect. But rather than trying to guess the right value,
I prefer to use the derived focus distance from the camera. We select the camera and drag and drop the 8 ball, in this case, onto this focus object field, and automatically the 8 ball gets in focus, and everything closer to the camera or further away from the camera gets out of focus. So let's go back to our bokeh settings here. So the circle of confusion radius, it's where we are going to tell Redshift how strong this effect will be. So if we start to use this slide to the right, the effect is really too strong, and the other way to the left. So in this particular scene, I like to use a value of 1. Now the power and the aspects will tell how the blurred pixels circle will look like. I'm not going to show these on this training, but if you want to know more about these two settings, please refer to the documentation. Okay, so now that we've got the vignetting and the DOF as we want, let's enable GI. So let's go here to the Redshift render settings, GI tab, and let's enable the brute force for the primary GI engine. And before I do so, please have a look into these areas here more in shade. Now they get light bouncing from the table surface, and we are getting color bleeding as in real life. For the secondary GI engine, let's use the radiance point cloud. As I do this, we are not going to notice any difference because this is a point-based effect, and as you know, the IPR right now, it's not going to take that into account. For us to preview that effect, we really need to switch to the bucket mode. And this weird path that you saw calculating, let me refresh. This is a radiance point cloud being calculated by Redshift. So this is how the final image would look like if we would render it right now. And as you can see, we've got a lot of noise and we need to tweak settings in order to clean all these. And that's what we are going to do next.
Okay, I'm going to render a preview using the original size. And as you can see, it's very noisy. So let's go here to the render settings. And here on the unified sampling, this is where Redshift really excels when compared to other GPU renderers. It's because it's adaptive, so it's going to use less samples when it needs less time to clean noise and more samples on more complicated areas. I know from my tests that I'm going to be using a value of 128 for the maximum and 16 for the minimum. And when we are using at least 128 for the maximum samples, we should use at least between 8 and 16 for the minimum samples. We shouldn't use crazy values like 1 for the minimum and 512 for the maximum. The unified sampling takes care of anti-aliasing, depth of field, motion blur. All other effects like lights, GI, blurry reflections, they need local samples, and the local samples always need to be greater than the max samples. We can see that the image looks a lot better right now. Let's take a snapshot and let's actually go into clay mode. Let's also take a snapshot. So here we can see that we are getting noise on the shadows. So let's go here to the area light and let's increase the local samples from 16 to 1024. And we can already see a difference between these two. So now it's a lot more clean. So let's also go here to the render settings. Let's go to GI tab. The brute force currently is only using 16 local samples. So let's increase it to 512 too. Let's give it a little bit of time to render. And we can see here, probably I'm going to zoom a little bit more. Here, these areas, we can see that we are getting less noise. Okay, regarding materials, and because the reflections are almost sharp, We don't need to go here to the material and increase the local samples for the reflection. 16 will do fine for the current reflection settings we've got. So let's go and put these back at 100 and let's render the final image. Let's get rid of the snapshots. So this is it, ladies and gentlemen. If you need to know more about the unified sampling or any other aspect, consult the online documentation. Thanks for watching.